Hello everyone, I am going to speak about orientation of the double bond. Okay, in my previous video I spoke about the stereochemistry part of it, and today I am going to speak about the orientation of the double bond. Okay, before starting my video I would like to start with a quote. The way to get started is to quit talking and begin doing. This was mentioned by Walt Disney. So unless or until we do many things, the world will not recognize you. So coming to the topic, orientation of the double bond. So in this, the regiochemistry and stereochemistry part of it will be explained for the reactivity of the elimination reaction. So regiochemistry of the double bond involves the reactions in which the elimination arises if more than one carbon have beta hydrogen. Okay, see in this example we have secondary butyl halide wherein you have alpha hydrogen is nothing but the chloro group attached to the carbon atom is alpha hydrogen, and the one side you have, on the right side you have 2 beta hydrogens, and on the left side you have 3 beta hydrogens. Okay, so here minus of HCl, the product formed is either 1 butene or 2 butene. Okay, so you find that there are 2 types of beta hydrogen present in this reactant. Okay, so next one, here again you find you have a benzene ring with CH2 Br being attached. So the beta hydrogen is a CH2 group and HBr is released. So what happens is benzene ring CH double bond CH2. Okay. So rules for major and minor product. Okay. So the first one is Breadit's rule. The double bond will not shift to beta head carbon. Okay. So here you have a bridged molecule. Okay. So you won't get the product on the bridged head. Okay, so the reaction takes place towards the right side. You have a Br and a double bond being attached on the other side of the carbon atom. Okay, so this rule is very, very important. The double bond will not shift to the bridge head carbon. I hope this reaction is very clear. Okay, rule number 2. Rule number 2 is, with unfavorable stereochemistry also, there is possibility of newly formed product, formed double bond to get into conjugation with some previously present multiple or aromatic ring. Okay. The third rule is, the directional shift of double bond in elimination reaction is decided by relative stabilization of the resulting products. Okay, and the double bond moves towards the more substituted carbon, that is CSIR rule, explained by heat of hydration and hyperconjugation. Okay, so ப்ராடக்டாக கிடைக்கிறது வந்து எது வந்து மோர் சப்ஸ்டிடியூட்டட் கார்பனாக இருக்குதோ அதுதான் வந்து நமக்கு மேஜர் ப்ராடக்டாக கிடைக்கும். Okay, see in this reaction you find that there is CH3, CH, CH3, CBr, CH3, CH2, CH3. Okay, and you find that on the left side this product is not much formed, whereas you find that on the right side you have carbon, double bonded carbon with 2 CH3 groups on one side and CH2, CH3 and CH3 on the other side. So this is a more substituted product. Okay, so this product is formed as the major one. Okay, rule number 4. Trans beta proton required anti-E2 mechanism active and is accessible when one bond shifting, double bond is shifting is possibility is there, and if 2 or more carbons are there, then trans beta proton, 2 types of products are formed. Okay, so CSIR product and Hoffman's product. So CSIR product is nothing but double bond shifting towards the more substituted carbon, and Hoffman product is double bond shifting towards the least substituted product. Okay, so எதில் வந்து கம்மியாக substituted molecule இருக்குதோ, substitutions இருக்கோ, அது வந்து ப்ராடக்டாக கிடைக்கும் Hoffman's. Okay, to explain this one I have given here, you have a molecule in which CH3 CH3, two CH3s are attached, and then here again another carbon with CH3 and SME2. Okay, so CSIR product means what happens, you have a this SME2 and the hydrogen gets removed. Okay, so you have double bonded carbon with CH3 attached on both sides, and CH3 and hydrogen is attached on the, this one is the CSIR product. Okay, and here you have Hoffman product as, see here the double bond has shifted towards the other side, so you have CH3 C double bond CH2 and H. This one is Hoffman product. Okay, so you find that in CSIR product the stabilization is more, the substituted molecules are distributed evenly. Okay, and that's why that is the major product. Rule number 5. Hoffman orientation is favored over CSIR product in syn elimination reaction. Okay, and rule number 6 is the radioselectivity is less importance for even CB reactions since it involves electron withdrawing group at the beta site. Okay, I hope these rules are very clear in order to explain about the orientation of the double bond in order to get the major and minor products. Okay, so CSIR rule and Hoffman rule will give you the explanation for the orientation of the double bond. So in my next video I am going to tell about the CSIR rule and Hoffman rule in detail. Okay, I hope this video was very clear. Thank you for watching my video. Thank you.